Okay.
All right. How would you start this problem here? Solving for x. Okay, so we can't do same bases, right? It's not going to quite be easy to do that.
Right.
So what can we do to find a way to get that x, to deal with that exponent variable x? What can we do to both sides of the equation?
Can we make it logs?
Yeah, take the log of both sides, yeah.
So log 2 of x equals log 7.
Mm-hmm.
Okay. And then we'd bring the x to the front of the log. Okay. Can we cancel out the logs or no?
Well, you want to get x by itself. So what can we do to get x by itself?
We can bring log 2 to the other side.
Yeah, yeah.
So log 7 over log 2.
Yeah. So that's acceptable, or you're plugging the calculator, but then that's, which will give you a decimal number. But log 7 over log 2 is acceptable. Yeah.
Okay. Okay. Number 2. We'd do the same thing. We'd make it logs, right?
Yeah.
Okay. And then we bring the x to the front.
Mm-hmm.
Would we distribute the x plus 1 with log 4?
Yeah, x plus 1 through.
Well, we then bring, so that would be x log 4 plus log 4 equals log 3.
Mm-hmm.
And then we'd bring log 4 to the other side, so it'd be x log 4 equals log 3 minus log 4.
X log 4 equals log 3 minus log 4. Yep, and then you can divide both sides by log 4.
Right.
I did it in a different order, but it's the same thing. We've gotten the same decimal number.
Okay. Okay. So negative 0.208.
Mm-hmm.
Okay. Number 3.
Number 3, yeah.
That's 7 times e x minus 3?
That's right.
Okay. How would I do this one?
Yeah, so we got to do something first before we can take the log of both sides. What can we do to clean that up a little bit more than...
Multiply the 7 times e x minus 3.
Yeah, we can't do anything on that with that left side. That 7 is not going to be able to do anything with that e to the x minus 3.
Okay.
But maybe we can get that e to the x minus 3 by itself, just like how the exponential base e, 2, and 4 are by themselves.
Oh, so we could divide, or we could do 57 divided by 7.
Mm-hmm.
So EX minus 3 equals 8.14.
Mm-hmm.
Okay. And then we take the log of each.
Yeah, I would take the natural log because base E and natural log have a way of matching up nicely.
Right. So X minus 3 equals natural log 8.14.
Mm-hmm.
And then X equals natural log 8.14 minus 3.
Plus 3.
Oh, plus 3.
Mm-hmm.
5.097.
Yeah, that's what I got.
Okay. Okay, number 4. This one, can you find, oh wait. Can you do
So
the same thing where you
yeah,
do?
same as number 3.
Okay. So I got E2X equals 2.5.
Mm-hmm.
2X equals ln 2.5.
Mm-hmm.
X equals natural log 2.5 divided by 2.
Mm-hmm. Good. And we want to make sure that the 2.5 is not 2.5 divided by 2, it's whole natural log 2.5 divided by 2. The 2.5 and 2 are not in the same places, so we can't divide those out.
Oh, okay. So it'd be X equals 0.458.
Right. Yeah.
Okay. For this one, can we just take the natural log of for each side?
Yeah, that's what I would do. Yeah. Number 5 is nice and ready, unlike 3 and 4 that required a bit more cleaning up.
Right. So X equals ln or ln 4 minus 3 over negative 2.
Yeah, that's right. Yeah.
Okay.
I found the decimal before that, but you would have gotten the same answer, I think.
Okay. I got 0.806.
Okay, let me see. Natural log of 4 minus 3 divided by negative 2. That's right. But did you do natural log of 4 close parentheses minus 3?
Let me try that again. Yes, and I got negative 1.613, and then that divided by negative 2, I got 0.806.
Okay, let me double check it. Natural log of 4. Yeah, you're right. I think I'm wrong here. 0.807.
Yes.
Okay, let me change that. Oh, okay. I did minus 3, but then I should have put a plus here.
Oh.
Okay. Negative. Okay, that's what you got again?
Yes.
Okay, all right.
Okay. Number 6. This one we're going to take the log of each side, right?
Yeah, that's right. It's a little messier because we got to deal with logs on both sides and exponents on both sides. So a few a little
Right.
bit longer than the previous problems.
Okay, so 2x log 5 minus log 5 equals log 7 minus x log 7. Then bring the x's to the same side.
Yeah.
Okay. Okay, so I got x equals log 7 plus log 5 over 2 log 5 plus log 7.
That's what I got. Good.
Okay. Number 7. Okay, 4x equals 8.
Mm-hmm.
We can make it then both 2, and then 2x equals 2 to the third.
Good.
And the 2's would cancel out, and then you have 2x equals 3, x equals 3 over 2.
Yeah, I took the log of both sides, which works as well. But yeah, I like how you look for common bases, and that will get you to the same answer as well.
Okay. So number 8, I'm going to bring the 4 to the other side. So negative 23 minus 4, negative 27. Can we then do negative 27 divided by negative 2?
Yeah, that's what I did.
Then EX equals negative, no, not negative, positive 13.5. We can take the natural log, right?
That's right.
So X equals natural log 13.5.
Mm-hmm.
Number 9's pretty easy.
Mm-hmm.
X equals 1.
Yeah. All this time, we did not have to check for extraneous solutions because we did not begin with log equations. So whatever we get is fine.
Okay. Okay. How would we do number 10?
Okay, maybe we can get this left side a little bit more descriptive. How else can I write natural log of x?
Log E of X.
Uh-huh. And typically, if I'm stuck in log form, I like to explore exponential form, and maybe that will get me some another perspective on the problem.
So E8 equals X?
Yeah.
And then can we take the natural log?
Nope, you already have your answer. You have X by
Oh.
itself.
Oh,
So a lot
right.
of times, once you get to exponential form, a lot of times just it becomes a lot more clear as to what your answer is going to be.
Right.
So,
Okay.
sometimes if you're stuck in exponential form, not coming upon a dead end, a lot of times taking a log of both sides will help you get to that X. But if you're in log form, if you're come up upon a dead end, you can always explore exponential form and see if that will help you get some clarity.
Okay. Okay.
And then we check for extraneous solutions.
Oh, right.
E to the 8th gives us no issues inside the parentheses, so we're good.
Okay. This one, 2 to the 5th equals X plus 2.
Mm-hmm.
So 2 to the 5th is 32.
Mm-hmm.
Equals X plus 2. 32 divided by 2 is 16.
Wait, 32 minus 2, right?
Oh, wait, minus, right. So 30
Yeah.
equals X.
Is 30 safe?
Yes.
Yeah.
12. 7 to the 3rd equals 25 minus X. 343 is 7 to the 3rd. So then that minus 25
Mm-hmm.
was 318, which that equals negative X. So negative 318 equals X. And that works.
Mm-hmm. Yeah, it's a valid solution.
Okay. This one I'm going to subtract 4 from both sides.
Mm-hmm.
So 3 log 2x equals 12.
Mm-hmm.
Could I do 12 divided by 3?
Yeah.
Okay, so log 2x equals 4. So 10, 4 equals 2x. So 10,000 equals 2x. So 5,000 equals x.
Yeah.
And that works.
Good.
Okay. 14. How would I do this one again?
So we want to eventually get that left side to look like this. So any properties that we can do to try to merge these terms together?
We could do log of x plus 2 times x minus 1.
Say it again?
Log x plus 2 times x plus 1. I mean, x minus 1.
That's right. Yeah, product property. Yep. Product property allows us to merge the sum of two logs into the product of the arguments.
Right. So then that'd be log x squared plus x minus 2
Mm-hmm.
equals 1.
Mm-hmm.
So 10 equals x squared plus x minus 2.
Right, got that hidden base, convert from log to exponential form.
X squared plus x minus 12
Yeah, got to get that 0 to show up on one side if I want to go through binomial factoring.
equals 0. Then so x plus 4 and x minus 3.
Mm-hmm.
So x equals -4 and x equals +3. -4 won't work.
Good.
So x equals 3.
Yeah.
Can we do 4 divided by 5?
Mm-hmm.
Okay, so natural log 3 minus x equals 0.8.
Mm-hmm.
Log e 3 minus x equals 0.8. So e to the 0.8 equals 3 minus x. E 0.8 minus 3 equals -x. So x would equal 3 minus e 0.8. Could you just leave it like that, or should you solve it?
Yeah, technically you could, but it's harder to. I guess you could plug this in to the x and see that it's going to be okay because the threes cancel out. But yeah, you can leave your answer in this in exact form. That's perfectly fine.
Okay. So 0.774.
Mm-hmm.
Okay. The logs can cancel out, right?
Mm-hmm.
So x plus 2 equals x squared. 0 equals x squared minus x minus 2. X plus 1 and x minus 2, so x equals -1, x equals 2. They both work?
Yeah, you're right. They both work. I thought -1 was an extraneous solution, but -1 works as well. I need to change that.
Okay. Okay. This one. So ln x plus 5 equals ln x minus 1 over x plus 1.
Yeah, quotient property. Difference of two natural logs would be the quotient of the arguments.
And then can your ln's cancel out?
Mm-hmm.
Okay. So x plus 5 equals x minus 1, x plus 1.
X minus 1 over x plus 1, right? Divided by.
Right.
Okay.
Yes, sorry. So then can I cross multiply?
Mm-hmm.
X plus 5 x plus 1 equals x minus 1. X squared plus 6x plus 5 equals x minus 1. What do I do after that?
Just like before, get everything over to one side.
Okay, so I would do x squared plus 6x plus 5 minus x plus 1.
Mhm.
So x squared plus 5x plus 6.
Mhm.
Okay. So x equals -2 and x equals -3. -2. -2 is not going to work. And -3 is not going to work.
Nothing works.
So no solution. Okay. Okay. I can do 2 ln 3x equals 10.
Yeah.
And then ln 3x equals 5. And then e5 equals 3x. And then e5 over 3 equals x.
E to the 5 equals 3x.
Oh, would I just leave the 3 on that side, or?
Well, the 3x is inside the argument, so it kind of has to stay together until the end.
Oh. Okay, so e5 equals 3x.
And then you can move the 3.
Okay. So then that'd be e5 over 3 equals x.
Right.
Okay. That's
And it should be fine, right? Checking for extraneous
yes.
solutions. No issues with being a negative or 0.
No. Seems like it works.
Yeah.
Okay. The log 5s can cancel out.
Yeah.
-4r minus 8 equals r plus 7. So -4r minus r equals 8 plus 7.
Yeah.
So r equals -3.
Yeah.
And that works.
That works. Yeah.
Okay. Number 24.
Yes.
Okay. Okay. This is log 7 x to the second minus log 7 y to the fourth.
Now you're just condensing. Not solving, just condensing.
Right. And then log 7 x to the second over y to the fourth.
Mm-hmm.
Okay. Log 9 a to the fifth plus log 9 b to the 15th. So log 9 a to the fifth b to the 15th. For the first one, I had log 7x squared over y to the fourth.
Oh, yeah, you're right. It should be y to the fourth.
Okay. And then I got that for 25.
Okay.
Okay. Log squared x to the third over x plus 3 to the fourth for 26.
Mm-hmm.
Okay. Do I need to make sure that whole thing's in parentheses?
Yeah, definitely. Yeah, I would say those 6 parentheses are needed.
Okay. Okay. Now expanding. Okay. 2 log 2x plus log 2y for 27.
Mm-hmm.
Okay. Uh, 4 log 6a minus log 6b.
Mm-hmm.
Okay. 4 log 2 8x minus log 2 5. Oh,
Mm.
okay. So 8 and x4 are two different things.
That's right. 8 and x
Okay.
4, 2 separate.
Okay, so log 2 8 plus 4 log 2x minus log 2 5.
Yes. Okay, log 3 12 equals x. Yeah, that's it. All you're doing is you're rewriting into log form.
Okay. Log 2 1/2 equals -1.
Mm-hmm.
Okay. ln E15 equals x.
Yeah, either form is fine.
Okay. Oh, I got ln E15 equals x.
Um,
With the
what did you
wait,
do for your first step? You took the natural log of both sides?
yes. Wait, no, hold on. Oh, wait, I see what I did. Oh, wait. No, because wouldn't, is the E the log E at the bottom?
Mhm.
So it's log E15, it's not log E15?
Oh, yeah, you may be right here. Oh, I converted into log form. Log base E of 15 equals x. I just converted from,
Oh, okay,
but you could also take the natural log of both sides. That could also work as well.
okay.
And we'll get the same answer.
So ln 15 equals x.
Well, it's natural log of e to the x equals natural log of 15. X comes down, natural log of e is 1, so that goes away.
Okay. So either way would work.
Either way would work, right?
Okay. Okay, 49 1/2 equals 7.
Mm-hmm.
EX equals 14. 2 negative 2 equals 1/4.
Mm-hmm.
Okay. Okay. So this one got shifted right by 1
Mm-hmm.
and shifted down by 3.
Yeah.
Okay. So our vertical asymptote is 1.
Mm-hmm.
Okay. So now we have to do the thing where we have to put like for it to equal 0, we have to do
Well, not equal to 0, but equal to what? So we have a couple of properties we're going to be working with. Log
right.
base b of 1 is equal to 0. That's a nice property there. And also
Right.
log base b of b is equal to 1.
Oh, okay. So you have to get inside the parentheses to equal 1.
Right.
So when x is 2,
Mm-hmm.
y is negative 2?
Well, let's see here. 2 is going to make this piece turn into what?
1.
Right. And what's log of 1?
0.
0.
Oh, and then 0 minus 3
Uh-huh.
is 3.
Negative 3.
Oh, right, negative 3. Sorry. Okay. And if we want inside the parentheses to equal 3, x is going to be 4, and y will be -2.
Right, because this 4 minus 1 is 3, log base 3 of 3 is 1. 1 minus 3 is -2. Yeah.
Okay, and then to find our x-intercept, we set it equal to 0, right?
Mm-hmm.
So x equals 28.
Mm-hmm.
So 28 zeros are x-intercept. Okay. Next one. It shifted left by 4.
Oh, did you finish? Did you fill out the rest of
Oh,
these? You did. Right?
yes,
Okay.
sorry. Domain is 1, infinity. Range is -infinity, infinity. And then our asymptote was x equals 1. Okay. Now number 40. That shifted left by 4, right?
Mm-hmm.
Okay, so we want it to equal 1.
First things first.
Oh, vertical asymptote, right. Vertical asymptote equals -4. So for my first point, I got -3 for x and 0 for y. And then
So I want my x plus 4 to be equal to 1/3, right?
right.
So let's put this down here. Make the calculator do the work for us. X plus 4 goes 1/3. Subtract 4 from both sides.
So 1 minus 4. X equals -11/3.
Yeah.
And that
Which
equals
is
1.
right. And this is around -3, close to -3.
Yes.
-3, -4. Yeah, because the base is less than 1, it's going to cause the graph to be decreasing.
Okay. Okay. And then to find the x-intercept, 0 equals.
Well, I think we already have it, right?
Oh, right. It's -3, 0. Our domain is -4, infinity. Range is -infinity, infinity. And then asymptote is x equals -4. Okay. This got shifted up by 3.
One more. What other transformation? Oh, there's two more.
Reflected over x-axis. And compressed by 2.
Actually, stretched by 2.
Stretched by 2.
It's greater than 1 because we ignore the negative. The negative is for something else. So we just look at that number to see if that number is greater than or less than 1.
Okay. Okay. Our vertical asymptote is 0.
Mm-hmm.
Okay. And then when x equals 1, y is 0. And when x equals e.
Well, when x equals 1, the natural log of 1 is 0. But let's figure out the rest of these numbers.
Right. So then 0 plus 3 is 3.
Right. 0 times -2 is 0. 0 plus 3 is 3.
And then when x equals e, y equals 4.
Yeah. So natural log of e is 1. 1 times -2 is -2. -2 plus 3 is 1. And there's one more nice property. We don't necessarily need it, but it's nice to know. This one, if I have log base b of 1 over b, that's equal to -1. So if I can get the reciprocal to occur, then I know this overall value is -1.
Okay.
So what if I made x 1 over
We made x 1 over e. That would be 2.
Yeah.
Okay.
Plus.
Oh, and then 2. Oh, wait. Oh, wait, because if you put negative, or not negative, if you put 1 over e, that would make that whole thing -1
Mm-hmm.
without the negative, right?
Right.
So then that would make it +1.
Oh,
with
positive 2.
Oh, we're not including the 2 either.
Right.
Okay, so that'd be 5.
Yeah. -1 times -2 is 2. 2 plus 3 is 5.
Okay. And now we find the x-intercept.
Yeah.
Okay, so -3 equals -2 log EX. Can I do -3 divided by -2?
Mm-hmm.
So 1.5 equals log EX. E 1.5 equals X. So 4.48 or E 1.50. Okay. Number 42 is, so that's shifted left by 6 and shifted down by 1. Vertical asymptote is -6. Okay, so negative, if X equals -5,
Mm-hmm.
Y would equal 0.
Well, the green portion will equal 0.
And then 0 minus 1
Yeah.
is -1. Okay. And then to get the parentheses to equal 0,
Not equal 0, but
no, equal, oh, right, the same value. So 2, that would be -4.
uh-huh.
And then Y would equal 0.
-4 plus 6 is 2. Log base 2 of 2 is 1. 1 minus 1 is 0. Yep.
Okay. Okay. Our domain is -6 infinity. Our range is -infinity, infinity. And then our x-intercept is -4, 0.
Good. I'll stop the recording here.